Hello, welcome to, I wonder if I'm missing Toni, and I think I might have forgotten to send her the links. I know I sent her a link, but it might have not been the correct link. Here we go. I didn't send her the correct link. That's the problem. I was wondering where she was. She's always here. So welcome to Happy Maths Hour. And poor Toni is going to be a little bit stressed when she arrives. And I'm just fixing a prop that we're going to use in a minute. And make sure I've got all my other ducks in a row. Let's see. Sorry about that. Is she here yet? I'm just going to find her and I'll be back here. That's not it. Oh, there she is. Hello. Sorry about that. I sent you the link earlier with the test and I forgot to send you the real one. Have you seen? I've got something magic. Remember I was making those squares for today. Are you ready for a little bit of magic? So this isn't a square. This is a pentagon. Toni, you have to look. You ready? So I made coloured squares.
Caroline, all I can see is a brick wall behind you. It doesn't come through.
I know. That's the magic. And look at this. I discovered that yellow does it too. Watch this. So I definitely have to share that with Gordon. But what I'm going to do is I'm going to turn off the screen behind me so that it works.
Well, I've just got a wall and a picture behind me.
Yeah, so I'm just going to have my. I thought I turned it off. Oh, there we go. Now, there we go. We can see them now. That's better. Brilliant. I'll just leave it with my green screen behind so that we can actually see the props. Yes.
So today we're going to be talking about paper, preferably scrap paper that you've already made good use of. So we are being very planet friendly, and it's amazing what you can do with scrap paper. And it could also be old newspapers or magazines. So I just keep a lot of that sort of stuff because we keep using it. And yes. So what we're going to be talking about today is having some fun with paper folding and learning some maths at the same time. So
and I'm going to turn off my camera because I've left my props over there. I'll be right back.
Okay, Caroline is going to do some wonderful things, as she often does. But what I'm going to do is to share my screen with you. And there we go. Share screen. And hopefully that will work. Well, I don't know. Caroline, what can you see? Can you see my screen? Can you see the slides?
No slides.
No.
Oh no, I do that. I do that part. I have to do this. Now we can see your screen. Yes, now it's one screen.
Good. You can see the slide, which is the title slide.
The title slide.
Now the contents.
Yeah.
Okay, so first of all, we're going to just tell you what we're going to do. And that first one is the Tangram puzzle. And you see there a little logo, which is a ship, a colourful ship. And that's made with Tangram pieces. So we're going to show you how to fold a piece of paper, make your own Tangram puzzle, and then, my goodness, there are thousands, literally, of different puzzles, lots of value out of that Tangram. And then the second thing we'll do is talk about paper sticks. Now, these are just an ordinary piece of paper rolled around some string, and you can make models, and you can do a lot. I mean, a huge amount with paper sticks. The third and fourth items for today are quite simple. They are little simple activities using a piece of paper that show very powerfully some geometrical ideas. So the first thing is talking about play. Now, I started to talk to Caroline about this earlier. And I said, when you teach young children, never ever just tell them this is what you've got to do. Give them whatever it is and tell them to play with it, or just let them play with it. And then eventually, after they've had plenty of time to play with whatever it is, you can come to the point where you actually have an activity in your own mind. You've got some learning activity that you're going to suggest that they should do. But in the early time, it's just free play where they're creative. But Caroline said, well, what did you say, Caroline?
Well, you didn't say free play. You just said play. And what you were being a lot more succinct when you said it. The first thing you have to do if you're under the age of 8 in any maths classroom, the first thing you have to do is play. You didn't say free play, and that is, so I said sorry, that was, you did now making that distinction of free play, and then I said it doesn't matter what age you are. The key to an engaged maths learner is that every time you go in the maths classroom, every time you start a new project, no matter what age you are, your husband Alan's the same, I'm the same, you're the same, when you start a new subject in maths, or a new, okay, we're going up to the next level, this lesson we're going to learn about this other thing, is having that sense of excitement. If you've got that sense of excitement, then you are, even if you're only playing in your head, even if you're only playing with a pen and paper, or just having a conversation with the class and discussing a concept, you're playing. And
the children should be playing. I mean,
children,
the teacher may
learners.
think it's
I'm talking
fun.
about the learners. No, I'm talking about the learners. Yeah.
I know you are. But the point is, the key is if the teachers can do the magic and get the learners to absolutely believe that this is going to be interesting, whatever it is. Yeah. And it can be the teacher's super enthusiastic, but if learners are not super enthusiastic, then that's not going to be much good. So let's move on. So Caroline, you're going to show everybody how to make the ship from the 7 pieces.
Just the ship. I'm not doing the tangram, just the ship, am I, at the moment?
You're just to show the ship.
The ship. Okay. I didn't have the picture ready for the ship. Hold on, I'm going to find it. Brain, engage, show me the ship. Got the ship. Okay. Right now, I'm going to change my cameras. It's a yacht. I'm going to change my camera. Now I know where the ship is. I'm going to change my camera. Now I'm failing. I'm sorry, Toni. I did not make the I didn't think the ship was coming up right now, so I didn't do it the other way around. But I didn't manage to get the board behind me. We're doing it on here. So we've got a ship, make it as higher up, as far away as possible. And going to make the ship. And it's going to look like this. You're going to have to tell me if it's visible. So
I can't see it. I can't see it, Caroline.
Oh, okay.
No.
Right, I'm going to make the ship. And then that's the sails. I'll tell you now if it's visible. Sails. That's interesting because neither of us can see what I'm doing. Right, there we go. So that is a sail. It's an angle like that. Can you imagine that's a sail? So that's 2 identical triangles. And then we have
another little
triangle,
piece of the sail.
A little triangle just there that's the front sail, the foresail. And then we have, you can imagine the bow of now you've got to get this right. This is part of the visualization process. Got to get it the right way round. So that's going to go there. And that's the I don't know.
Then there's a tiny triangle on the left of it.
I haven't got there yet. If I put that on, I'll get lost. I'm going to put my square there, and then I'm going to put the tiny triangle. Wait a minute. This must be. See, look, now this is all the beauty of how Tangram is helping you, and you're not doing maths, but you are looking at proportions, and you are looking, because I realize that this triangle can't go at the back of this. Which way round does it go? We've got to work out which way right there. It would go there, and that's too big. So I'm like, and this actually for sale is too small. So I'm getting my proportions right now and putting that on there now. Which way round does it go? I want it to go so that you've got the angle going back, and that one. So that's not it. That's not it. If I turn it round that way, there we go. And that is the key. Now I'm doing this live. You're seeing this live. That's the key to Tangram.
Yes, Caroline, but you need to move your camera back so we can see the whole thing. We can only see part of it.
I'll raise it there.
So I'm sorry, folks. We should have practiced this earlier. Well, that's lovely. Now, Caroline, next thing you're going to do is to show us how to, very quickly, Caroline, because we've already spent 15 minutes and we've done very little. Just show us how to make a square, and then very quickly, because I'll talk while you're doing it.
Yeah.
Okay. How to make the tangram from a square of paper.
So I'm gonna first of all make a square with a small piece of paper because it's smaller and easier with what I've got. You just literally fold any piece of paper across so that you're, and then that line follows
Caroline's
there,
and then Caroline's going to cut that out.
And then,
yes.
then you would cut that out. But I've already done that with this lovely orange piece of paper. So we've cut it out, we fold it over, cut it out. Now we're going to use, for the tangram, you make that fold really nice and sharp. And then we need to find a place in the middle. That is the most important thing you're doing with this tangram. If you get this right, you'll be grand for everything. So you fold that exactly in half, but you don't flatten it. The most important thing with this is that you make a little kink there, which finds the halfway point, and you can see there, and then you fold this over like this, and you cut this piece out. Then once you've cut that piece out, you fold the whole thing in half again. Then you can cut two big triangles here, and then the remaining trapezium you cut up, and that is a bit more complicated. So there's a link in the description. Don't know which way's down, in the description below, and and there's a lovely video that Toni and I made, that Toni just is doing the descriptions and shows you how to make it, and you get all the other different shapes from this remaining trapezoidal strip there.
Great. Yes, we have the link to that. It's called Make Tangram by Paper Folding. It's on YouTube, and if you want to make it yourself, you can stop and start that video, go back if you missed something, follow the directions, and make your own tangram pieces. You have 7 pieces. Now, what you should see on the screen now is a shape that looks a bit like a bird, possibly. It's grey.
Oh, yes. Yeah.
It's grey, and that has got symmetry. So that is actually a learning activity. It's all about symmetry, and you can make hundreds of different things from your 7 pieces, like the little green man here who's running along, okay? And this originates in China, and there's hundreds of little Chinese people and animals. And if you go to the Aiming High website, you will find there is a whole lot of different challenges and puzzles to make, including the one that you see that the little green man is running towards, which is a hexagon. You can see it's not regular, but you should see how those 7 pieces fit into there. Now, those are 2 very, very easy tangrams puzzles, because actually the lines that separate the pieces are marked. It's much more difficult when the lines are not marked.
It's much more difficult, but you can see how powerful the whole process of visualization is as you solve it, because you start off doing simple things like this, and I'm following the lines. Then when you do it yourself, you start off this way and get a feel for the shapes. And it's hard enough when you can see the lines, but when you can't start that way and then move on to not seeing the lines, and it's so powerful when you solve it. Woohoo! You feel so good.
Yes, and Maths Toys is the name of our YouTube channel, the name of the AIMSEC YouTube channel, and there you will find a lot of videos, and we're adding to them more or less daily. We're adding another video at the moment. And we've chosen this symbol of the tangram as the logo for Maths Toys. So do go and have a look, and not just at this tangram paper folding one, but at other videos there. Now it's time for a break, and after the break, we'll take you on to the next bit of exciting paper folding.
Oh, right, we are back.
Okay, we're back with paper sticks. Now, the story behind this is that Caroline does the most wonderful maths shows to entertain often very large audiences with balloons and bubbles. And the balloons she uses are long sausage-like balloons that will make more than a meter. Okay. And so she does wonderful, wonderful activities. Well, rather, she doesn't do the activities. Do you, Caroline? The audience, the young people from the audience get involved with doing these activities. They get very excited about the mathematics, and they learn quite a lot, which they'll soon forget if there's nothing that follows. So Caroline and I were worried about this, you know, helping the teachers to follow up in the maths lessons, the exciting, motivating play, if you like, that the children had enjoyed with Caroline. And so we couldn't expect the teachers to be inflating dozens of balloons and using balloons in the classroom. So we were thinking, what can we do that would be just like the balloons? I mean, not as beautiful and as much fun, perhaps, but they could do everything with our paper sticks, we decided, that they had been doing with balloons. And all you do to make a paper stick is you get some paper and you roll it. So in the picture here, you see some newspaper to make a measuring stick 1 meter long. Now you need to have a ruler, and you can see if you look closely at this that there is a ruler laid out on the floor. I think it was on the floor in front of the paper, and you get the paper, quite a few sheets of newspaper, and fold it as you see there in 3, and then you roll it up as tightly as you possibly can to make a paper stick, and you can cut it to be exactly 1 meter. And then you mark off on on your paper stick, you mark it 10 centimeter intervals, and then at one end, you don't need to do it all the way along, you can, you mark 1 centimeter length, so that the anybody can take this piece of paper now, rolled into a stick, and can use it to do measurements. Now,
I'm showing them, Toni, and I've just realised mine are 5 centimeter intervals because of the meter stick I used. So yeah, so these are 5 centimeter intervals in case anyone's thinking, And I've just made this up this morning, and it's got a string through it so that you can make a meter. So you can make the huge 3D shapes with it as well.
Yes, but generally we just use it for the meter long for this particular purpose. So scale drawings are hugely important in all applications in many fields, all sorts of building plans, architectural plans and building plans, all types of design work for making many things, the accurate design done with a scale drawing. A model aeroplane, to test the aeroplane in a wind tunnel before you go to the expense of building a proper big full-size aeroplane. All the sorts of plans, they are drawn to scale, and of course maps. And learners should get experience of doing this by measuring something in the playground, or perhaps more interestingly a football pitch or something, and drawing accurate scale drawings. There's a lot of maths in that. Now the next idea is to be playing and creating, and what can you make from paper sticks? Now the next sort of paper sticks that we invented were paper sticks in the middle of, well, near the top, just under the word TETS, you'll see a paper stick there. Now that's quite short, and it's got a piece of string through the middle. It's rolled tightly and secured with some tape. And Caroline, you've prepared some paper sticks, haven't you?
Yeah, I'm showing one to the camera right now.
And if you make 18 of them, and with 5 of them you make the rhombus shape you see there, and the 6th one goes with it. And then the other 12 you make into a square, which is 3 by 3, right? A big square.
It's kind of more of a snake that they can see on the camera right now, but it's basically a loop of 12.
Yes, but you can make it into a square if you hold the 2 top corners, let it drop down, then the bottom will sag a bit, but you'll get more or less a square.
Yeah, they can't see that because it's horizontal, but yes, we can also make it into a dodecagon, which is
they can see it on this. They can see it on the slide.
You can see it on the slide. Yeah.
Now, what the slide is telling you is that with 18 paper sticks, the sort that is all the same length, the sort that have got string through them, you can tie them together like the orange shapes. All right, so you can make a square, lay it flat in the shape of a square, and the other one you can have as the rhombus with the single stick, and you're ready to solve the puzzle. You're ready to make a tetrahedron and also to make an octahedron.
So I'm not demonstrating how, am I, Toni? Yes.
You could, yes. Why don't you make the octahedron?
Make the octahedron, yeah. The tetrahedron, the way I use the tetrahedron is to say manipulate it, move it around. Just keep moving it until you get the shape that you're looking for. And I have to say there's a little bit of a clue here. I will give you that little clue, and I've put that away. And now I'm going to make out of this, could be a square. I also do it as a 3 by 4 rectangle. I'm going to make an octahedron.
Notice that Caroline is making triangles, because all the faces of the octahedron are triangles, actually equilateral triangles, because the sticks are all the same length.
It's much easier if you've got more than one person doing this, by the way.
Yes, actually, isn't that true of doing a lot of maths, Caroline?
Yes.
I really do favour most of the time having the learners in the classroom working in pairs.
Right, I've made it, but because I've only got one pair of hands, it's kind of keeps coming. Doing what I want it to be doing. Oh, that wasn't it.
It's a pity we're not in the same place, isn't it?
Yes. Well, that's COVID for you. Right. So there's triangle there, triangle going down, another triangle going down, and then another triangle going up.
I think you've shown them enough, Caroline.
Yeah, okay. Lots of triangles, but can I tell you a story? As a year 6 class took a loop of 12 balloons, meter length balloons, huge long balloons, took them away, took the loop, and I gave them the challenge. They took it back to their class. 15 minutes later, they showed up in the session, interrupted everything, saying, look, we've done it. So basically, keep fiddling with it, and you can make an octahedron out of a long loop of 12 sticks.
Now, I was going to give them a hint, well, a word of warning, and that is all the edges are one single stick.
Oh, yes.
What I find sometimes when people try to do this, they have 2 sticks sort of side by side, and then they won't have the 12 edges that they need for their octahedron. So
that's not even that's not a hint. That is, I call it a rule. It's
okay.
Yeah, because that's it's really hard to do it without.
Now, Caroline,
it's not really hard. It's not possible to do it. And the thing is, it's not really hard at all. It's not possible to do that challenge with doubling up.
Caroline,
the edges.
Have you got your 3 coloured squares to show them the octahedron made another way?
You might be able to. Fun. There's 1 square, 2 squares, and I had to turn off my green screen behind me because they disappeared. There's 3 squares.
We can see them.
So the challenge that what I say is make a 3D shape out of them, and so most people make a 3D shape like so, which is grand, and it is a 3D shape. It's a prism. If you can see it, it's like a tent.
But it's got double edges.
It's got doubling up. So they have done it correctly, though, because they've made a 3D shape, which is fine.
No.
Well, because I don't tell them the way I do this challenge is I don't tell them that. I tell them make a 3D shape. They make a 3D shape, so we're making progress. Now you have to make a 3D shape without doubling up any of the edges. And so the secret is using the diagonals. So you can see from above you've got, and they must be squares. They must remain squares. It must be squares. You can see the 2 squares there. And can you now visualize what to do? I can't let go. I've got another square in my other hand. Where are you going to put that 3rd square?
Now, what Caroline does on the stage, or when she's doing this with a group, she has 3 people, often 3 children, each of them to hold a square, okay? And she then encourages them and talks them through it, really, and they make the octahedron.
Well, I don't give them instructions. I'm helpful, but not. I don't. Yeah. I let them work it out, like I just did with you guys. I might make it diagonal, but I don't dig them the answer.
But this is beautiful when it's finished. It is absolutely beautiful. And the reason I say that is because each of those squares forms a plane of symmetry. A plane is simply a flat surface, all right? Well, of course, you'll say it's only a square. It's only the rim of a square. Okay, that's true. But imagine that as part of a surface, and it's like a plane mirror, and what's on one side of it is the same as what's on the other. And if you like, that's a hint about making it. And there's not one plane of symmetry with the octahedron mirrored top and bottom, or left and right, or whatever. Look at my screen again, and right. Now look at the octahedron there. Now, can you see the flat square in that picture? And can you see that the top of the octahedron, which has got it's like a pyramid on a square base, okay, is reflected below that plane of symmetry? And then if you can see that there's a second plane of symmetry, which is around the outside edge of this picture, then there's a bit that points back, which is slightly fainter, and there's a pyramid that comes towards you, and you can almost imagine it popping out of the screen.
Can you just tell me when you're ready, and I can just show them one of the giant balloons with people around it?
Yes, okay, and the other one, I'll leave you to look at for yourself. So what we've essentially done is to take 3 squares as the 12 edges, so that's 3 times 4 is 12, and the children or the participants in the show will make the octahedron, and then you can see the property there of the planes of symmetry. So Caroline, what are you going to show us?
So those are meter length balloons, and you can see that the purple and the green squares are vertical, and then you've got the orange square horizontally through the center of it, and you can see the scale of it by the size of the people that are holding
Lovely.
it. This is actually in Musenberg with Toni and the people from Ames.
Well, I hope people can see that.
Oh yes, they could see it.
Okay, and behind you see a picture of Einstein, and that was done in South Africa, yes. That show, and you saw Caroline there. I think she might have had her head cut off, but she was there as Bubbles the clown.
You can't see the face, which is why I used the picture. But you've got Einstein, and the initiative is called The Next Einstein Could Be African. So
yes, that's our slogan.
That's rather
it's
lovely.
Called,
yeah.
It's called the Next Einstein Network, and the slogan is The Next Einstein Could Be African, and that's why we work to help empower Africans to improve their education so that every child has a chance. I think we're ready for the next break.
We are. I'm just looking for it now. Right. And after the break, what are we doing? What's the next exciting prop that I've got to get ready?
It's called trifold. Not trifle that you eat, but trifold.
Oh, I'm disappointed. No, I'm not, because I love thinking. Right. So I'll get my triangle ready. Okay. And I like this one. Now, Toni, I have to confess that I had a bit of a job making a triangle that was the right size, but that wasn't, it is not, I promise you, it's not equilateral. I mean, not equilateral, it's not isosceles triangle.
It's not special.
I promise. It's not special.
We wanted to show you something mathematical about triangles in general, and not just a property that applies to every single triangle in this whole world, and not just to isosceles triangles and right angle triangles and equilateral triangles, which are special. Now, we're going to start with play now. And what that you see is my green leather desk. And on the desk, there were quite a few different shaped triangles. And what I would do with a class of learners in school or at home is to say, everybody make a triangle, make different triangles, and when you've cut them out, make 3 folds. What shapes do you get? And then to talk about the shapes. Now, this is not where we're going eventually, but this is to start us off, this whole idea of making 3 folds in a triangle, which produces different shapes, and we can talk about them.
So
any folds anywhere.
Here. I'm going to fold this here, and I'm going to fold it there. And oh my, okay, all right. I've ended up with a quadrilateral.
Well, the whole point here is just play around.
I just played.
See what happens.
Fun. Yeah,
Yes.
and I could actually attempt to make all different shapes, and I'm actually making discoveries just by doing it. Think, oh, actually, and then I did one earlier. I'll just show. I have to show them this one. I just started folding this piece of paper, and I started with a rectangle, and I ended up just coincidentally with it was two. I was attempting to make them two identical, triangles back and front, but then I turned out that my inside folds were also the same area, so I had three identical triangles on top of each other. There you go. The discoveries. I had lots of fun. It was a very enjoyable process.
So what we're trying to do is just to let the children be free to find out different things about triangles by folding the piece of paper. But then there's one thing that the teacher will have in mind with this trifold activity. And here's the diagram. Okay, and Caroline is going to show you this.
Right, so you said it's better if the base is one of the long edges to make life easier. Okay, now give me the instructions.
Particularly matter, but you just have a triangle. And now we're just going to talk about this bottom line now. And what we need to do is to fold through the vertex at the top, which is in the picture that you see is labeled A. And we're going to fold C, pick C up and fold it over.
Pick C up.
C
Sorry,
up
I missed
and
that.
fold it over so that it's going to lie on the line, that baseline still, but it's going to lie somewhere else. It's going to be such that Caroline's going to make a fold through A at the top.
Oh, so A is going to be the top. Okay, so I'm going to take that. So that's going to follow, so that the bottom edge is going to fold down along itself, and the apex, the new apex is still, the A is still going to be the apex.
Yes, but what we'll have is when you make that fold, if C has gone over to the same, on the same line as that baseline, and you will have folded along this line AR in the diagram everybody's looking at, which is sort of a brown dotted line.
Yeah.
And the two angles that are on either side will be right angles. Because
that's a right angle and that's a right angle. Yes.
Right. Now unfold it and flatten it.
Yeah.
Okay. Now what you've done by that fold is constructed, just by folding, a perpendicular from the vertex A down to the base BC. And that perpendicular in the diagram you're looking at is labeled AXR.
So that's X. Oh, we've got R anyway.
Well,
we don't have X yet.
You don't have X yet. No. So the next thing to do is to pick up A. You should have it now flat. You should pick up A and fold it down till it precisely comes down to coincide with R.
I'm just going to make that line a bit deeper so I can see it nicely. So it comes down exactly down to R, and then squish it down on.
Crease it along that fold line and then open it up again.
Well, that's a much more sophisticated word than mine. I said squish it down.
Right. Now that fold line in the diagram you see has got two arrows on each end, which shows that it's a line that is part of a bigger line. It's just a line segment PQ, and it's parallel to the baseline, it happens, and you can prove that by a little bit of geometry, but that doesn't, not really what we're talking about at the moment.
So that and that parallel, but that's not, but
yes,
but it is, but the fact that it is parallel,
it's going to make a rectangle.
Process. Yeah, exactly.
Yes. Yeah. And the line on the first fold and the line on the second fold intersect, they cross each other, making four right angles at that point, and that point is called X.
Okay.
Yes.
Yeah.
And in the picture there, what Caroline has lifted up, the triangle APQ, right, was a few minutes before was folded back to correspond to, lie on top of, if you like, the triangle PQR.
So that's APQ and that's PQR, like so.
And those two triangles are exactly the same, because Caroline will show you they can lie on top of each other.
It's obvious, yeah. I mean, yeah.
Yes.
That the triangle below it is made by the triangle above it, basically, yeah. Yes.
Okay. Now it should be flat again with your triangle ABC, and you've done two. You've done two folds, but the first one was just to find R. It's in a different color because it isn't part of our trifold, really. I suppose we could have called it quadrifold, but it's the three black folds that are important, okay, marked in the black lines. Now, the next thing is to pick up the vertex B, right, and bring it across to right to correspond with R. Just bring it across. Do the opposite to what we did with C. No, not quite. Yeah, because C came over. Didn't we take C to R? No, we took C past R. No. Oh, we did. I remember now. So, but this time, forget C for the minute. We're doing B next. Just bring B over and make it kiss R. Okay. Oh, the little kiss. There you go. And crease that fold. Yep. Okay. And then open it out. Now, what you've done is taken the triangle PBR and you've folded it in half. So PBR, and now we've folded it in half to make two triangles out of one. Yes, it's double. I mean, obviously, so double because it's sitting on top and it's got the same area as the one below it, obviously. Yes, okay. We're nearly there, because now you need to do the same thing with C. You want to make C kiss R. It went past R the first time. Ah, of course it did, yes. And now this time it's got to go and sit on top of R. Now I'm doing this with card. It's a lot easier, just let you know, everybody, that it's easier to do with paper. I'm doing it with card to make it a bit easier for you to see it. Nice and clear and colourful and stuff. Okay, now I'm going to... So I'm drawing these freehand as well. If you're going to draw these lines, do use a ruler, because it would be you get a better result. That's a T there. Okay. And I'll draw the triangle. Yes. Okay. Now then, what Caroline has drawn for you is a rectangle. I think you can see it, and you can see it in the diagram on the slide as well. Now, Caroline, fold those three flaps down. Now, you want to take your fingers away, Caroline, because they're hiding what I want people to look at. No, put it back. No, I'm just folding. Yes, I'm folding it. I can't take my fingers away. It won't stay. Right. Oh, no. Use some tape if you want to hold it down. Well, somehow or other, hold it down so that the three flaps lie flat on top of the rectangle. That's the negative part of using the card. Okay. It's okay. Oh, well done. I think she's. What did you use? A little bit of press stick there or something? Sellotape. Right. Now, what do you notice? It's a rectangle. It's the rectangle that I drew on the piece of paper. It's the rectangle that you've got on there. What about the pointy bits that come together at that point? They're all in exactly the same space. And we were talking about the area of the. You've done it 3 times. We've got the area of the triangles, and the area of the triangle below is the same. But this is not really. I mean, that's what I mean is it's the same area. It's the same. Well, yes, you've got half the area, haven't you? That's you've got half the area of the original triangle.
Of the big triangle, of the original triangle. You've got half the...
Yes, yes.
See, I didn't leap to that. I leapt to each triangle is halved, but I didn't leap to the rectangle is half the area of the triangle, but it is.
The area of your original triangle is, right, twice, because it's now double thickness, twice the area of that rectangle. The area of the rectangle.
Yeah. Yeah.
And the area of the rectangle is half the base times half the height.
Oh, no, wait. So that's, yeah, because that's half of that and it's half of that. Oh, my goodness. So the area of the rectangle is, so it's 2 times half of the base times half of the height, which is the rectangle. That's easy to work out because it's basically it's the length times the width. And in this case, the length times the width is half of the base of the triangle times half of the height of the triangle. And we know that because we've just halved the triangles. Oh, my goodness.
Now, 2 times a half is just 1.
Oh, well, yes, no, that's just silly. Yes, 2 times a half is 1. So we don't need, so we've got the base times half the height. And then that rings a bell. I seem to remember the area of a triangle is half the base times the height.
Yes.
So we've just demonstrated it. Half the base times the height.
But we can also...
Beautiful.
But there's something else.
Now. Yes.
There's something else. But this is not about area. This is about angles. And why I didn't want you to have your fingers on top of the angles is that I wanted people to notice something about the angles at R.
Okay, well, I noticed that all 3 angles together, oh, it's flat. If you add that angle plus that angle plus that angle, it's 180 degrees.
But what were those 3 angles?
Oh, they were random. Because you deliberately asked me. They weren't random. I thought you deliberately asked me to make a one that had no right angles.
Oh, well, in that sense, yes, you're right, Caroline, in that sense. But the point is, take any triangle, fold it like that, and whatever triangle you have, the 3 angles add up to 180 degrees.
Yes. Yeah, I said that.
So everybody in the class, so as you've got a class of 30 learners, they all do it, but with different triangles. They'll all get the same. They'll all get the same result. That for their triangle, whether it's Caroline's triangle or Toni's triangle or Tom, Dick, or Harry's triangle, they'll always get 3 angles that add up to 180.
They always, and do you know what? Because I knew about that. What I've always done in the past is I've literally ripped the triangle, the vertices off of the triangle, and then stuck them together on a straight line, so that I could prove that it was a straight line. But this is so much more it's beautiful. It's just a beautiful. There's so much in that.
But the problem with the method which many teachers do use, I have to say,
yes, is
that it could be that. It could be anything but a straight line. You know, it looks straight. But the angles might add up to 179 degrees or 183 degrees, and nobody would notice the difference.
And look how much I'm struggling to get them just lined up nicely. Whereas this is beautiful, Toni. Absolutely.
And that's our trifling, delicious trifold.
I like it. A deliciously trifling trifold. I love trifle. Yeah. But without the sponge. I'll have it without the sponge. Thank you very much. So we don't have any sponge. There's no. You like the sponge. You can have the sponge, and I'll have the jelly. This is lovely.
Okay, so let's have another jingle, another break, and then we'll come back for our last.
Sorry, I pressed the button too soon. Our last. What do I have to have ready, Toni? Do I have to have anything ready?
This is making 60.
Ah, I know what to have ready.
You've not made it yet. Caroline,
I
you're just young. You haven't made it yet, have you?
I haven't made, not yet. I've only got another less than a year to go, so I can make 60, and then I'll be able to do this puzzle. I don't think I'm going to get the job as a radio or TV producer. I might get a job as a presenter, but I don't think they'll give me one as a producer. A
lot of people are having to do everything themselves, whereas they'd have had assistants in the studio before COVID, wouldn't they? And you're having to do everything for yourself, so you're doing fantastically well. So I hope you've got a piece of paper, and it can be
not just any piece of paper. It's a scrap piece of paper, reused.
Great.
Previously loved.
Now what we're going to do is to make an angle of 60 degrees, and then we're going to make an equilateral triangle.
No, wait, how do I make an angle? Wait a minute, angle of 60. Do I need my protractor for that? To make an angle of 60 degrees?
No, you don't.
I don't need my protractor. Wait a minute, we're going to make it. What about a ruler and a pencil? Do I need that to make an angle
No,
of 60
I don't
degrees?
think you actually do. It's all folding this time.
Folding? Oh, wow. Okay, go on. I'm ready. Let's go.
And then we're going to ask people this question, because we won't have time to show them the answer. We'll ask them, why does this fold create an angle of 60 degrees? And then they can try and work that out for themselves. And why is it an equilateral triangle equally? That's a good question. And if they want to get some help, then they'll have to go to my aimset.ac.za website, where everything will be explained. So Caroline,
so you've got to remember making 60, ladies and gentlemen. Right, go ahead. Take your
piece of paper, fold it in half lengthwise, and crease it down the middle.
Lengthwise, the long way. This is usually I get right over the top of something like this. It might not be as precise as I would like to make it, but it's okay. Crease down the middle. Okay.
Now take the bottom left-hand corner, and in my diagram there's a red arrow that shows you lift up that corner and you make a fold, and this isn't easy, so you just take a few moments to get it right. What you have to do is to make sure that one end of your fold is on the bottom right-hand corner, and the corner you lift up precisely sits on that first fold line.
Right, okay. A little bit fiddly. So that's got to be exactly on the corner there, and that's got to be exactly on the line there. Is that a bit further, just a teeny bit further? I think we've got it. Now squish that one down.
Right.
Okay. You see, you said crease it down. I said it squish it down again.
Now, what you have got is a quadrilateral now.
Okay, let's have a look at the whole thing.
But you don't unfold it now. You leave the triangle flat down. Okay. And the angle there, which on my diagram is the fourth one in the sequence, you'll see X degrees marked, and this angle is 60 degrees. Isn't that wonderful?
Not that angle. This angle.
It was obviously 60. You've got two angles of 90. You've got an angle that's bigger than 90.
This one here. This angle here. This one here is 60.
Yes.
Right.
Yes.
That there is 60 degrees. Okay.
It's easy peasy to show that that's the case, but you just need to understand a little bit about this magic equilateral triangle and what happens when you fold an equilateral triangle in half. Okay, and you've got to imagine an equilateral triangle there. That's all I'm going to say to you.
Can I just finish making the equilateral triangle very quickly?
Ooh, no. Yes, you're going to, but now that's Yes,
Okay.
you are going to.
Yes.
So
Okay.
the next thing is that, can you see the diagram, Caroline? Is that
Yes, I can.
helping
I
you?
can see everything.
So
Yeah.
you need to fold the left hand edge down to meet the fold you've just made. And now you've got another, that will actually give you another angle of 60 degrees. And you've almost got an equilateral triangle, but there's just a spare piece that will, that you need to sort of fold back and
So
tuck
this
in.
here is that one there, tuck that away. And then I've got, let me just raise up the camera a little bit. And I've got an equilateral triangle. Oh my goodness.
Isn't that beautiful? And it's so simple. I mean, I just love it because it's really, really simple.
It's very simple. It's once you get that first trick with that first fold, once you work that out, the others just kind of are obvious. And that's beautiful.
Yes.
That's an equilateral triangle, and it can be proved. And if we go to the making 60, just Google maybe 60. But if you're watching this on the replay, it will be in the comments. That
yes,
link, which isn't there at the moment.
So we've more or less reached our time. We've shown you some activities, some things to do with just with scrap paper, just with something that's not going to cost you anything, that's you might have thrown away, and yet what value you've got out of it the second time round. 4 different activities. The Tangram, which actually makes you, there are 7 little pieces, all set to do hundreds of different puzzles, with the paper sticks, where you can make, we showed you a tetrahedron and an octahedron, but you can make lots of shapes with them, both flat shapes and 3D shapes. We also showed you the trifold, and finally this making an angle of 60 degrees in an equilateral triangle.
I'm just going to finish up with the cube, and one of the lovely activities on Namesec is that you make a cube out of the sticks, and it's a foldy cube, and you can then literally, this is free play, really is free play. You make the cube, which is fun in itself, and then you find out what happens when it goes flat. You can flatten it this way to make a rectangle. You can flatten it again to make a square. You can flatten it to make a hexagon, and you can just flatten it to make a pile of sticks. There's all kinds of things you can literally, that's a toy in of itself.
You can also find out with these structures a little bit of structural engineering. You can find which shapes hold themselves up and which shapes collapse.
And I'll give you an idea about the cube.
Yes. And what I find in a classroom is that you can, if you're clever, you can hang the shapes up so that, in fact, even the cube will form a cube when you hang it. So get a sort of laundry washing line and hang it near the ceiling of your classroom, and hang these shapes that you've made with your sticks.
Or your child's bedroom, but get them involved in figuring out where to put the strings on to hang it. Get them to do that part, and then you can do the hanging up part, but get them to figure out where to put the sticks so that it holds strings, so it holds its shape.
But this is part of a policy I would actually encourage all teachers to have, and that is to have the children's work on display, the maths work that they have done, so that not only is it motivating and they like to see their work up there, but also that it reminds them of the mathematical ideas that they learned from doing whatever it was on paper or with these paper sticks or whatever. So in the classroom, there should be lots of posters and models and things hanging from the ceiling, if you are lucky enough to have a school where you can do that. I remember I taught in a school where I didn't have my own maths room, I had to spend the day between lessons running from one classroom to another. And that was really not good. And then I moved to a school where I had my own maths room, and it was a wonderful place because
Heaven.
every wall was covered with children's work. And, you know, we had it out on show, and we could swap it round for new stuff and talk about it when they'd forgotten a word or something. It was on the wall. Anyway, our time's up, Caroline.
It is. Thank you very much, everybody, for coming in and watching Happy Maths Sal. Thank you. Well, thank you, my co-presenter, my author, it all comes from Toni. Thank you, and Toni Beardon, and see you next week, 5 p.m. London time on Relax TV.